This example comes out of section 2.5, the quotient rule. To start off with, I'll do a similar example to what I did at the beginning of the product rule. Let's say we had a function that was y equals, x to the 7 divided by x squared. Well, I know that I could simplify that a little bit and say that's x to the 5, and then the derivative of that, correct derivative of that, would be 5x to the 4. Some students, if you didn't identify that you could simplify before differentiating, might say, oh, well, can I just do the derivative of the top over the derivative of the bottom? And they would try something like this and say, oh, the dy by dx, could that be 7x to the 6 divided by 2x? If you look at that, that definitely doesn't give you the same answer. It gives you, 7 over 2 or 3.5x to the 5th, which certainly doesn't match what we got above by doing it correctly. So there's more to a quotient rule than just taking the derivative of the top function and dividing it by the derivative of the bottom function. So let's first of all, I'll show you what the quotient rule is, maybe show a little bit where it comes from, and then we'll practice it a couple of times. So we're given just in general, a function where we put a quotient, f of x divided by g of x. If we want to take the derivative of that, it turns out that the quotient rule is not that simple. We have to take the bottom function multiplied by the derivative of the top minus the top function multiplied by the derivative of the bottom, all of that divided by the bottom function squared. So that's a bit of a handful if we use it for the one above, which again you obviously wouldn't need to use it for, but just to see how it works, the derivative should be the bottom function times the derivative of the top minus the top function times the derivative of the bottom divided by the bottom function squared. So let's simplify that a little bit. I've got 7x to the 8 minus 2x to the 8 over x to the 4. So 5x to the 8 over x to the 4 equals 5x to the 4. So at least, if nothing else, the answer matches, and we have a rule that works. Fortunately, you will get the quotient rule on a formula sheet, and not something that you need to memorize, but obviously knowing how to use it is pretty important. Let me show you the proof of it. If you know the product rule, the proof of the quotient rule actually isn't that terrible. So we start off with the same function saying, well, big f of x equals little f of x over g of x. If I multiply both sides by g of x, I can say that this equals f of x. So now if I take the derivative of this, I would need to use the product rule to say, well, what does f prime equal? It equals big f of x times g prime of x plus g of x times f prime of x. Now, what I was looking for in the first place is big f prime, so if I just solve for that, I need to, first of all, subtract f prime x minus f of x g prime x. That's going to equal g of x f prime x. Now divide both sides by g of x. It doesn't quite look like the quotient rule as we had it up above, but if you recall the fact that big f of x was f of x, little f over g, you can say f prime x minus f of x over g of x times g prime of x, all that over g of x. And just so we don't have a fraction over a fraction, multiply the top and the bottom by g of x, and you end up with f prime times g of x minus f of x times g prime of x over g of x squared. Kind of an unusual way of proving something, but if we have the product rule given to us, we can use it to show that the quotient rule works.